product designer will do all the FEA analysis, all the designing considerations, all the environment considerations. They will design one of the part. All right, they will design one of the part with the design, with the all the manufacturing considerations. Even they make all the complete part. But is this manufacturable? Is this I mean, like, is this whatever we have produced in some software? We have produced one part which is fully robust, fully matching with environment in the sense, child part in the sense, surrounding parts, right? So is this part is matching with surrounding requirement or not? Like harness is there, and some other panel is there. So whether that is matching or not. Okay, so that is most important thing. What designer will do? How much is the thickness? How much thickness reduction can he do? So those things, when he consider and make one part, but still the question is there whether that part, whatever is available on the software right now, is it can be produced physically? That is the biggest question we have after R&D, after doing all the product development, after release of the drawings, after uh, 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 design the product. All right. So now it comes to the manufacturing area. So when it comes to the manufacturing area, here, uh, what as a die stamping engineer is like, he can build this or get it built from the supplier. Is like, from the supplier we used to get this as a casting one, okay, and from that casting we need to produce this shape. All right, by machining, by multiple analysis also we need to do. And so life cycle is, once the product has been designed and it came to the manufacturing level, so there we need to find out, we need to see whether that product is manufacturable, whether that is producible, whether that we can produce it with all the dies available or not. So for that, uh, uh, see, we will be having a blank sheet available. All right. We will be having a blank sheet available. Now we have to stamp it, and for that stamping, whether that sheet can take that shape or not. You might have seen the chapati. Just a quick example. You might have seen the chapati. If you roll the if you roll your stick onto the chapati dough, uh, will it take the desired shape? Will all the thickness is spreaded all over the chapati or not? I don't think so. We can spread every time in all the chapatis. It is the same. All the thicknesses every time it is same everywhere. It is not possible. So similar way, if you see, if we put it in the die, whether that sheet metal has been spreaded properly or not. Steel is costly. It needs cost. If you have uh, 1 square foot or 1 mm also more sheet metal, that needs cost. So we need to optimize that cost also. 1 mm is also going to be drastic when we go for the mass production. So if we reduce, or if we can, uh, just a moment, my internet is going to, I'm going to change my internet. 1 second, please. Hello?
Sir, I can some disturbances created from your.
You are getting disturbance?
Yes, sir. Some disturbance is creating.
Yeah. Why? Because power is out, and now I changed my internet thing also. It's sounding. How to stop that sounding? 1 second. Is it okay now?
Yes, sir. It's okay now.
Okay, all right. So yeah, now no one can stop us. So is this going good? I mean, if someone be interactive, it will be helpful for me. Going good or not?
Yes, sir. Actually, the
Hello?
students will be interacting, or if they have any question, then they will be asked at the end of the session. Otherwise, in the
Yeah,
middle.
whenever. Yeah, got you. Okay.
Okay. And if
So
all students are having a query, then they will be post your query in the chat box also.
all right. That will be okay.
Yes.
Okay, I will give some time later. I mean, I will take some pauses between my presentation, so you can keep that question in your mind and you can ask the question. I will give the time because this is a long session again, so it will be helpful. Like I mean, in the middle of the presentation, we can have some query session also, right? So yeah, so. Till here, whatever we saw, whatever we have seen so far, do we have any question? You can come up with. This is open for everyone. Just 5 minutes. We can have question session there, and we will go forward from there. Students or friends, you can come up with any of the question. Either it is audible. I mean, uh, if you want to speak, you can speak up.
Sir, is it, sir, firstly, good afternoon, sir, from my side.
Yeah, yeah, sure,
Sir,
sure.
I have a question that, sir, if we want to get into R&D of sir, MNCs companies or other automotive companies in our sector, sir, does the software skill matters the most, or you need to be good at other things also? So I mean is that if you have learned some of the software just like KDR, SolidWorks, ANSYS, so is it sufficient to get into the R&D department, or we need
Mhm.
some more skills?
Actually, as a student, it is a good question because once you go out of your engineering, definitely people need what do you know, right? So, as of now, what I would suggest is, or basically when we go for recruitment, we don't see software skills mostly. Okay, if you know software, and as a fresher, if you know software, it is additional advantage, but it is not mandatory. Okay, if you have a basic knowledge or basic understanding of the things, how you manage the things, how you understand the things, how you take up the things, what domain you are interested in, so that matters. Software, basically, I learned software when I completed my engineering. I learned software. There are 13 software, 13, 14 software I learned from Central Institute of Tool Design. But all those 13 software I forgot by now. I have 15 years of experience now in industry. I never used all the software at all. Okay. When I started my career, I started working on ProE as a software. ProE or CATIA or Unigraphics or ANSYS, these are all tools, and these are all always updatable. Okay, so we cannot, as a student, as a fresher, we cannot be dependent on the software because we are not developing software. Okay, and software, whatever this software you see, these are all tools for an engineer. Okay, so this software will be used for making your desired thinking. You are getting my point.
Yes, sir.
Yes, sir.
Hope that answers your question, right?
Sir, just
Hello.
like you said, you go for recruitment. So, sir, can you please give us a guide that what you look up for in as a good um person to
Engineer.
get selected?
Correct. So, uh, first thing I'm going to, as let's say you are an engineer and you are a fresher and you came up for the interview or these things. So basically, I cannot expect much from you, but yes, I should be able to expect like how was your academics, how you performed in your academics, what are your interests, what are your strengths. All those things I'm going to look into. If you have this software knowledge, or if you are aware of this software, if you know the basics of software, I mean, like what are the like engineering drawing, you might have gone through that engineering drawing, right? If you are
Yes, sir.
aware of that, if you know applied mechanics, if you know strength of material, if you know basic machine design, uh, as a design engineer, I'm going to look into this for sure. Okay, how you are going
Yes,
to
sir.
design this, what is your approach, how you are going to approach it. So those things I'm going to look into. And if you approach it good, if you have a good explanation, if you have a good communication on that explanation, I'm going to observe everything. All right. So
Yes, sir.
uh, so yeah, I think you got my uh, explanation, right?
Yes, sir. Thank you so much,
Yeah,
sir.
so these are all things I'm going to observe. Anyway, any other question related to whatever we have gone through so far? Hello, any other student want to come up with any question? Anyone? Okay, so let me ask you a question. Uh, what do you understand by diphase, and whether whatever explanation I'm giving it, is it really understandable or not? Anyone can give this answer. Hello, Harshvardhan, who are speaking right now?
Yes, sir. I am Harshvardhan
Uh,
Patel.
yeah, Harshvardhan. So, whatever we have talked so far, whether that is understandable or not, I mean, like, do you want detail kind of explanation?
No, sir. I understood completely, sir. That what I need
Okay.
to do to pursue my career.
So, we are going good, you mean?
Yes, sir. Very good, sir.
Okay. Okay. All right. So, Deepti, we can take it forward from here. Okay. All right. We'll go and discuss some more things out of this. All right. So I'm going to have little more deep dive into it, and we'll see how it progress in understanding. All right. So once the product comes to the manufacturing level, now what is our responsibility as a manufacturing engineer is like, I have to see whether that product whatever has been developed is manufacturable or not, physically it is uh, manufacturable or not. So for that I need to go for some analysis. So that needs, I mean, basically I'm talking about all the side panel, all the outside panel, basically all the panel how we are manufacturing. So uh, is it manufacturable or not? For that I need to go for one analysis, like formability analysis, whether that part is formable or not. Okay. So whether that part can take up the shape, physical part shape or not. So for that I need to go for one analysis called formability analysis. So for formability analysis also we should be aware of strength of material, applied mechanics, and machine design. All those things we should be aware of. Okay, we should be aware of, even we should be having hands on too. So if you see some of the pictures here, okay, this is the picture of the B pillar of the vehicle. Okay, B pillar means how what is the B pillar, A pillar, and C pillar. So I will tell you. So this pillar, whatever is comes front side, front side of the vehicle, this is called A pillar. Okay, A pillar having interface with hood, fender, which is comes over the wheel arc. Okay, so fender is one of the part. which is also a outside body part. Then A pillar comes. A pillar is having interface. I mean, like interface with all the internal surroundings. If you see this dashboard, this dashboard also comes over here. This outer body structure also comes over here, and then roof panel, and then glass panel. So all those things, this is having interface. So when we design it, we need to consider all other surrounding. Based on that only, this will be designed. How this will take the shape. So based on this surrounding only, we can take the shape. Okay. Based on that surrounding constraints, based on the strength, but based on material and requirement of the strength, testing, everything. So that's how this shape comes. So that is called as A pillar. A pillar will be having other side RH and LH. Those understanding will be should be there. After that, we come on B pillar. So B pillar having interface with front door, rear door, roof, and seal. Front door, rear door, roof, and sill, floor. Okay, sill and floor. So these are all the interfaces are there. Along with that, it is going to take an impact of the seat belt. Okay, so seat belt again impacted with when vehicle is in full speed, and let's say sudden impact comes, the seat belt is going to pull the whole B pillar. So how the strength should be, we can understand with that, right? So this is B pillar. Again, A pillar, B pillar, and here one more window comes. That is called quarter window. Between quarter window and the rear door, there will be one more pillar. This pillar. Okay. This is called C pillar. Again, if someone dash from backside, it should have a strength so that person should not get impacted. Internal inside passenger should not get impacted at all. The vehicle, whatever vehicle we design for the safety, basically for the passenger. Okay, vehicle safety is not important, but passenger safety is utmost important. So whatever the component, whatever the part we design for passenger safety, passenger, driver, everyone. So which is costlier? Person cost is more important than vehicle cost. So we design everything for the passenger inside. All right. So here now I'll take it like this is the B pillar area. This is the B pillar area. All right. So here we go. We will see some of the die faces, some of the dies for hood. This is hood, and this is again on hood also, or whatever the part you see, that will be considered of like class A. Do anyone knows what is class A? Harshvardhan?
No, sir, I don't know, sir.
Okay. Uh, Assuming that if someone knows, can speak up. If not, I will anyway explaining it. So class A is the thing which is visible from naked eyes to anyone. Okay, if you are sitting inside the car, whatever you see on the vehicle is class A, whether it is dashboard, interior, or roof side interior, or A pillar interior, or if you stand outside of the vehicle, whatever you see from the naked eyes comes under class A. Whatever you see from your eyes, that is a class A, and that will be developed by styling engineer. Okay, and who is designing this styling and all? Those will be kind of craftsmen and architecture people will design all those styling things. Okay, so styling thing is the most important thing. No designer, no product designer, no manufacturing engineer is going to play with that styling. Okay, so product developer or a manufacturing engineer will develop the B side only. What is B side? B side is the, let's say, if this hood is whatever you see is class A, but whatever the behind things, behind this hood, whatever you are not able to see is B side thing. Okay, let's say some flanges are there. These flanges will be used to uh, attach this hood onto the vehicle. So if we make some attachment behind this, you cannot see any of the attachment which is outside. If anything has been designed outside of the vehicle, that means you are not a designer, you are not a manufacturing engineer, or you are not a product developer. Okay. First thing, that is violating the design rules. Okay. So whenever we design anything, as a product engineer, as a manufacturing engineer, or as an engineer, whatever we design, we have to respect class A. And whatever we design, we have to design on B side, not on A side. A side thing we are not going to play at all. So because A side thing will decide your if any vehicle is there. If you see this A side thing, whatever A side thing, nobody has played anything on the A side. Okay, nobody has played. But this A side thing is always visible to customers. All right. Only the mandatory thing like this door latch, what you see, this fuel latch you see, or fuel latch, whether it is electric plug charge or whether it is fuel pump, whatever, some slot will be there. So, but whatever you see, this door latch also, if you see that square shape, so that square shape is also a class A. So whatever the things we design on the B side, not on the A side at all. All right. Here again, how we do not have to think of all these things, but as a manufacturing engineer, we have to produce this shape, this class A shape. So this impression will we can get with this surface on this die face. How the life cycle of the manufacturing the part is like, first design product shape. Product shape came to us. Manufacturing engineer will analyze it whether it is manufacturable or not. Then it goes to like die face, like how we have to create the shapes. We have to build shapes, outer shapes. I'll tell you later on coming forward. So die shape we produce. That die shapes or die faces, this complete, let's say this is completely a die face. We have got some impression. So that surfaces will go to NC programming. NC programmer will program on that so that whatever the casting we had received earlier, that will be like pre-machined and then remachined. Remachined means fine machine we call it. So that fine machine will milling operation will be there. After that milling, after milling operation, once NC programming is done, so that programming will be feeded to CNC. So in CNC, milling operations will be happening. After that, to get this shape, basically, grinding operation will be there, and after grinding, stoning operation will be there. Okay, to get this class A as it is, like it is visible onto the vehicle. So this class A shape achieving is not an easy thing. Okay, this die cost, let's say one die is there, first die. This part shape I'm going to build in 4 stages. First is draw die, after that trim die, after that bend die, and after that pierce die. So this is the sequence basically we follow for any, not for every part, but for most of the part we follow the sequence. Okay, first thing first, whenever the sheet metal part is there, we have to go for draw die. In draw die, see, uh, whatever you see on the screen and perpendicular to a screen, one axis will be there. That is called Z axis, or we call it press axis. Okay. So in press axis, whatever shape we can get, one shot. Okay. So most of the shape we can get in one shot. That will become our draw die. So this is called as draw die. Okay. So most of the shape of the hood we got in one shape. But what about the flanges? What is developed by designer? Whatever the attachment shapes about, I mean, like some bend shape were there. What about those? So those also, if you see, some extra materials are there. All right. So if you see some extra shape which is visible on the die, okay. So that shape is going to trimmed out in trimming die, okay. And after trimming, little bit shape is still there. So this is a kind of a flanging die or bend die we call it. So that is going to bend inside B side, okay, and that will take a desired shape of it. So here, any bend effect, any bend effect or any crack effect or any wrinkle effect should not be visible on Class A at all. Any questions so far? Harshvardhan,
No, sir. No, sir.
you got the point? Like what I
Yes,
was
sir.
explaining, what is draw die, what is trimming die, and after that, what is flanging, and after that, how we get that shape
Yes, sir.
on different sequences, right?
Yes, sir. Yes.
Yes, sir.
All right. Okay, great. So this is so most of the analysis will happen, or we have to do the analysis on draw die only. Most of the most analysis part will be done in draw die only. Reason, once draw die is fixed, in other dies basically we carry forward the shapes. Okay. That is the important basic thing, uh, or overall uh, life cycle of the manufacturing of the part. Okay, here most of the dies I worked on, so I can explain you any of the die. You can see this is the side panel outer, which is comprised of the uh, front door and rear door. Okay, this side panel outer is having a class A from here till here. Rest of the thing is class B. Okay, only these things is visible onto the vehicle. If you see, when you go to the vehicle or in a car, you see this is the important thing which is visible, and nothing will be visible on this class A. Nothing will be visible. What I mean to say is no cracks, no wrinkles, or no any kind of dimples or dash on this class A. Every operation, whatever operation is being done on class B only, which is not at all visible. All right. On first look, it is not at all visible, that B class. All right. So whatever the analysis we do, what kind of analysis we do on the draw die is, I'm going in deep dive a little bit, so be attentive please on that. So what kind of analysis basically we do on class A thing to get the desired shape of this class A, and nothing should be affected onto the class A is actually one more thing before going ahead, wanted to tell you, like whatever shape we have achieved, it should be properly fit and finish is one of the most important criteria. Fit and finish, gap and flush, these two things are most important thing after getting the desired shape out of all dies. So once I got this shape, now I have to put it in the die, in the press machine. Okay, I have to, I mean, like blank shape, I have to put it in the, that stage is called tryout shape. Once machining of the die is done, now it is time to go for the testing thing. So testing thing, how test will be performed is like, we will put this dice onto the press with the proper pressure, cushion pressures. Basically, we need to produce there, not produce. Basically, we need to feed in pressures. So with that pressure, this will be taking its shape, die shape. So what are the how we test it? So uh, we have to see where the cracking is coming onto it, where is the thinning is coming onto it, whether this material is this whatever the blank we have, whether that is stretched properly or not stretched properly, how we measure the thickness at each and every point, how we see the flow of material, how the material flows onto uh, everywhere equally to get the desired shape. All right. So for that analysis is there, and once let's say our product came out perfectly, now the part of life cycle is it will go to another testing. It's called zebra light testing. So you might have seen on the internet or on YouTube, there will be a zebra testing. So zebra testing is what we will do is, let me take a snapshot quickly. Snap. Okay. Come on. Okay. So is my screen visible to everyone?
Yes, sir. It is
Okay.
visible.
So I'm going to draw something. Okay. So let's say if I see in this view, okay, if I see in this view, so something of this shape will be coming up. Okay. So what is zebra lighting is, I have an arrangement to see this, and I will put this on pivot table, one of the pivot table. Okay. So I will put this part on this one, and zebra lighting means all the lights will be arranged something like this. Everywhere lighting will be there. Okay. Now, if I turn this, I can see the waviness of this part. You got my point? I can see the waviness of the part, where the waviness is coming. So that thing I have to mark it. This area is wavy. So I have to mark it, and I have to fix that area, particularly onto the die, because die is die face. So die face is only giving me the impression of it. So I need to find out that area. This is called zebra lighting. All right. So that is one thing. Another thing is how to see the flow of material, whether the material is flowing all the way properly or not. So you might be aware, or you might not knowing or knowing, whatever. So if you see uh, at the draw operation, we will be having one blank sheet. Okay, we will be having a blank sheet. What we need to do, we need to each this in the sense, there will be electrode and one liquid is there. So with that, with the help of that, we need to give the round shapes over onto this throughout the panel. Round shapes, exactly round shape. Okay, because this sheet is flat, we have to etch this. This is called etching. Okay. And once we get all the round shape all over, now I have to go for the draw die. Okay. I have to go for the draw die. After blanking, I have to go for draw die. Okay. I'll write that up like the stages thing. Draw die, number one. After that, trim die. After that, draw, trim, bend. Bend means or flange, and then pierce. This is the basic sequence of bigger parts. Okay. So for draw die, I have to do this etching thing. I have to take this part shape onto the draw die on the press machine and stamp it with the cushion pressure. Once I stamped it, okay, are you able to see my screen or not?
Yes, sir.
Okay. So once I stamp it, I can understand. Let's say it take the draw shape of something like this. Okay. So this will be having those round shapes, right? So those round shape will somewhere it is long, somewhere it is this long, this way. So however is the material is flowing, that round shape will take shape of it. That way we can understand where the material is flowing. Any question on this? Hello?
Yes, sir.
Any question on this? Like
No, sir.
how that etching thing will take the shape? Or what is etching?
Yes, sir.
Hello?
Can you explain, sir,
Yeah.
etching?
Etching thing. Etching thing is simple thing. Um, one electrode roller is there. Okay. One electrode roller is there. One liquid is there. I don't remember that liquid name actually. So we apply that liquid and we will keep one cloth over here. Let's say I keep a cloth here, and belan, chapati wala belan.
Yes, sir.
Okay, so such kind of a stick will be there. Okay, so here one cloth will be there, and under that cloth, uh, the strips. One strip will be there, will be having round shapes on it. Still, still strip. That strip we will put it up here. On top of it, cloth we will put it up here, and we'll apply a liquid and we'll roll it. Roll with that balloon. So balloon stick. So that impression of the round thing will come on. Once we have done here, we have to shift it here, and that's how we get all the etching thing. Okay,
Yes,
so
sir.
we need to mark basically this round thing here. These are all exactly round thing, 1 mm dia. Okay, so like that round thing will be there all over the panel. And if we take this panel onto the die thing and press it, if we take that, press it. This is upper die. And this is lower die. And this is our blank. All right. So here, after punching it, the material flow within this die. The material flow, the question was how to understand the flow of material. So this is one of the way. This is the can understand the flow of material. All right. Once we understand the flow of material, we have taken that draw shape, whatever the impression is there, we have taken that impression here. All right. With all etching thing has been taken its own shape. Round shape has been elongated somewhere uh, according to the requirement of the shape, right? That round etching thing will take the shape, correct? Yes.
Yes, sir.
All right. So what we need to do here, we need to place this on one table. All right. We will place this on one table. This is one table. Sorry. This is one table where we place our draw die here. Not draw die, that draw panel. We call it draw panel. Okay, it has some shape. So here, what we need to do, we need to put one coordinate system. Okay, one coordinate system with a magnetic dice. You know magnetic dice? You know magnetic dice? Ludo dice, which is having
Yes,
one,
sir.
two, three, four
Yes, sir. Yes, sir.
dots marked on it. So that
Yes.
kind of coordinate system on the magnetic dice will be there. So that we need to put it up here at the corner, one of the corner where we can see everything. Let's say I put at this corner. Okay, from here I can see the whole part. So at different places, I'll put some dice shape here, at most important corner areas. Okay, I'll put dice so that I can see all the coordinate system, and I start taking pictures. I took picture from all the angles of this, 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 this. Like this, I covered taking picture from the camera. One camera will be there. I have to take, I mean, like manually, I need to take these pictures and feed it in all the pictures, all the pictures I have taken. I'll feed it in one of the software called Orgus. Okay, Orgus. I'll feed these pictures, all the pictures in Orgus software. That software will collect all the pictures and sequentially uh, it will create a complete panel. Okay, and it will show where is the thinning happening and where is the thickening happening and where are the wrinkles happening or where it is where it is having tendency to have cracking or wrinkling thing. Okay, so before you got this point or not?
Yes,
Hello,
sir.
Yes,
you got the
sir.
point how this Argus work. So this is called as Argus study for understanding the panel thickness all over how we have uh, how the material has been flowed onto the die. Okay, so that is one important thing I uh, told about the testing. So that is how we understand where is the thickening happening. Another way, before coming to all this dies and the manufacturing thing, draw die and the panel testing and all that thing, before that, one testing or not testing, basically, let's say we got one product here. This come to the manufacturing floor. Here we need to do formability analysis. Formability analysis on draw die. Okay. So whatever the test, etching test I told, that is the testing on the physical die or physical panel or physical testing. Okay, but this is whatever testing I'm going to explain to you. This is a testing which is called virtual testing. So virtual testing means once we develop the draw die phase, we need to feed it in one software called AutoForm or PAM-STEM. There are multiple softwares. Now the software comes in picture. PAM-STEM, LS Dyna, or Autoform, or there are more softwares for formability analysis. Even in CATIA also, even in POE also, Unigraphics also, we can do these testings. But few of the software having more capability doing that or giving the desired result. So, which is like Autoform, Parmestam, these softwares are more predominant in the market right now. So those software most of the industries are using it for analysis purpose, for this die face analysis. So here I'm going to take you to one of the result of, so all these dice we have developed after that, after the analysis. So you might have seen this picture. You might have seen this picture in your engineering. Yes? Hello?
Yes,
Yes,
sir.
sir, it's difficult.
Yeah, you have seen this picture in your engineering, right? So this picture is the result. This whatever the parameter you see, this is called forming limit curve. This is the limit curve, and this is the minor strain. This is the major strain. This is what is the basic basic thing. And you see those etching thing what we have given, right? This etching thing, this etching thing. All right. So let's say this etching took some shape. Okay, this shape. So in etching thing, that is physical thing, we understood like how the material is flowing. We can see physically that one onto the draw panel. But let's say virtual thing. So this shape is kind of inbuilt or feeded already into the software. So based on that, let's say once we have punched the upper die onto the lower die between blank is there. So this parameter, within this parameter, it will show whether it is whether our die face is safe, whether that desired shape is manufacturable or not manufacturable. It is giving wrinkles, it is giving it is tending to give the wrinkles or tending to give the what is that, cracking, thinning, uh, I mean, uh, whether our material is properly stretched or not stretched. So this is the uh, basic scale where we can find out our limit, forming limit, whether it is safe or fail. All right. So this is the important thing, how our material is started, how it take uniform elongation, necking is happening, or total elongation is happening. You can see this is one of the picture here that we saw on any material, like it start, and after elastic plastic stage it start to get fracture. So this study is most important study you might have seen or you have to do it to understand the future prospect. So industries are using this one. Okay. If anyone asks you question on forming, so he will definitely ask the question on this for sure, whether you have understanding on this or not, whether you understood this properly or not. So if you not understood in your engineering, it will be difficult to cope up with the flow of work in industry. Clear? So one more example, quick example. Here you can see this. This is our scale, main scale. This is a safety zone. In the corner, you can see my cursor, right?
Yes, sir.
Okay.
Yes, sir.
So this between these two range, between these two red lines, this is a safety margin. Within this, if your material flows, means you are safe. Okay. If it is going beyond it, it is failure. If it is coming behind it, safe forming region is this one. This is safe forming region. But we do not have to be in safe forming region. We have to stretch the material so that we can reduce the material. If we reduce 0.1 mm of 150 by 150 panel is there, if we reduce 0.1 milli also, 0.1 millimeter also, if we go for mass production like 5 lakh vehicle, if we are going to produce, so 0.1 will accumulate to lot of material, right? So uh, optimizing the material, this will help. Okay. So one of the good thing is there. So this will help us to optimize the material. This will help us to find out the failure area. So if you see, uh, if we go in this range, orange range, it will show us like excessive thinning is happening. Okay. And if we go in this blue zone, means wrinkle thing is happening. What is wrinkle thing? What is thinning thing? What is cracking thing? What is overlapping thing? Let me tell you that so in proper way. Let's say if you have a 1 milli thickness sheet, okay, if you stretch it, okay, up to some extent, if you stretch it, okay, so wherever you hold the material in hand, so that will not stretch properly. Okay, that will be a thick material. Okay, but where it is stretching, it is stretching in middle of somewhere. Okay, it will stretch somewhere here, right? It will stretch somewhere here. Then if you more stretch it, it will go to fracture. Okay, so whenever the thinning is whenever the cracking is happening, that means it is happening because of thinning thing. Material is stretched more, excessive thinning is happening, excessive stretch happened there. Actually panel, let's say, I'll take one example quickly. Let's say this is one of the panel you have. You stretched in all the direction. Okay. If you stretched in all the direction, somewhere it is stretching a lot, somewhere it is not stretching a lot. Depends on the geometry of the required shape. Okay. So let's say if it is stretched, means you know this bending. Oh, sorry. Okay, you know this bending curve also. If it is, this area is called as compression zone, this is called as tension zone. Everyone knows it. Yes, compression and tension zone. So whenever the stretching is happening, means tension is happening there. Okay, and wherever the thinning is happening, thickening is happening, material is getting thick somewhere. So thickening means compression is happening. Because of compression, thickening will happen, and because of thickening, wrinkling is happening. One important thing, because of compression, there will be thickening, and because of thickening, wrinkle will be the result. Okay. And because of tension, there will be overstretching or thinning will happening. And because of thinning, cracking will happen. So this fundamental is clear or not? Hello?
Yes, sir, it's clear.
It's clear, right? So this is the same fundamental we have to apply on the material. All right. So when we go here, we understand this. We can understand it clearly now. What is happening? Okay. So wrinkling is happening means, let's say insufficient stretch. Insufficient stretch means it is not stretching properly. That means in that area we need to do some tweaking in the surfaces or tweaking in the shape so that this stretching can happen properly. Our ultimate aim and goal is to have that panel, sheet metal panel or sheet metal sheet should be optimized and extract as much as output we can extract out of it. We should be able to get the desired shape in optimized material. That is the aim of overall formability analysis. Got my point? So you can see one more thing. Wrinkle. I tried to capture as max as possible to explain you, but this is this is a overall picture of it. But in depth, if we go, it will be having more detail. Okay, but overall picture is the same. Wrinkling thing, wrinkling tendency will be there. Okay, working zone is this area. Insufficient stretch is this area. Okay, this all the results we see in one of the graph that software will produce. One of the graph that software will produce is this graph that will bring all the results on this scale, so that you should be able to understand this scale where your material is in this graph. So what are the areas you need to work out? Okay, so this is the scale basically. Any question on this scale? Anyone can ask. Either it is faculty or student, anyone can ask the question. Hello? Hello? Am I audible?
Yes, sir.
Yes, sir. So anyone can come ahead and ask a silly question also is okay. Any question? Or everyone understood everything? All right. Let's move ahead with that. So this is one of the example of the wrinkles. You see on the, after that forming analysis, on the virtual analysis, we understand this is a class A. Do you want to see this kind of dimples on your car? Anyone say, yes, I will sell my car to him. Anyone want to see this dimple on his car? This kind of dimple, this kind of wrinkles, or this kind of bump shape? Anyone want? I can give it. I can give the car. Okay. So no, I don't think so anyone want it. So this kind of dimples or wrinkles are the results of our bad draw shape. We have to work on that draw shape. If you see this area is kind of like the material is flowing inside. This material is flowing inside. Here more material is there. Here more material is there. This will be trimmed out. This is a waste for industry, automotive industry. So this is the material where we have to reduce the material. But we cannot see it comes in roll, one bigger roll. So we cannot avoid this kind of material to be removed out and get that from the supplier. So we have to accept it. We have to go with that. So here is one bead factor I just mapped here to control the flow of material onto the die. So let me take one quick example. Oh, sorry. Okay. Oops. All right. So hopefully everyone is able to see this. This is this one is my upper die. This is my lower die. I'm just showing you one exaggerated drawing. My drawing is not so good, but I'm just trying to explain you that what is this area, what is this area, and how the material is flowing inside it. Okay, so let's consider this area. Okay, here what is this called basically? This is called draw bead. Okay, this is called draw bead. There are multiple names of it. There are multiple functions of this. So draw bead we call it, or flow bead we call it, or lock bead we call it. Okay, this will help us to flow the material inside the die. Let's say if you have a panel, something of bigger panel like this, we have to the draw die will be the upper die will be somewhere here on let's say we keep our blank shape over here. Okay, we kept our blank shape over here, and then it has to come down. This draw die, upper die, will come down with some force. Okay, so first it will get in touch with first point over here. Okay, and then when it comes till here, the material between these two will get start locking here. Locking locking or we can say flowing the material. So now what I'm going to do is let's say red pen. This is your upper die. This is your lower die. Okay, and this is your blank shape. What will happen if you have less gap between these two? This is a control area, control of material. Like what happen when we draw? It will flow also, and it will lock also. This two functioning is happening in this area. In this particular area, two functions are happening. When it lock means, when let's say if it is lock means material is locked here. Let's say if you hold on both the hand, here you hold, and push this from here. So what will happen? If you hold it tightly, it will start stretching. In this area, stretching is happening. All right. In this area, stretching is happening. And if you have a more gap here, so material will flow also. Material will flow in this direction also. So two things are happening basically. So one is locking, and one is uh, flowing also. So we call it lock and flow bead. Okay. So this is the fundamental function of this draw bead. So what we call this force, we call this force is called uh, bead factor. Okay. If we reduce the bead factor, if we reduce the bead factor means we are reducing the gap between these two. If we reduce the gap between these two, the stretching will happen. If we completely lock it, stretch will happen till it get cracked. So optimized bead factor has to be there. This is something what we can play with to control the material. Any question on this? Hello, Harshvardhan or Nitesh or
The
anyone?
active participation from your
Preeti
side. If the students have
or
any
Dipti?
queries, then they are free to ask. Please ask.
Okay, all right. So yeah, this is a just pause for any question they have. All right. Okay. I assume everyone is clear with that. Now I'll move forward a bit. So this is the bead factor basically we have to optimize the flow of material. That's how we uh, identify the area the where the stretching is happening, where not the stretching is happening, wrinkling is happening, or anything. So based on that flow diagram or flow limit diagram, we can understand which area is giving us the problem, and how to fix that problem is like somewhere we need to create a less gap or more gap. We can identify that area. Okay. So yeah, now I'm going to share some of the videos basically. Okay, some of the videos I'm going to share about the dies only. Yeah, 1 second. Yeah, I'm going to explain also. Let me share that with you. Okay. Is my screen visible?
Yes, sir.
All right. So if you see, this is one draw die. We are going to see it here more closely. So if you see, this is a lower cushion draw die, and this is lower binder ring. There are more details into it, but mostly we have to concentrate on this area. This is called as lower shoe. This is press pins. This is press pins. Then press air cushion transfer plate. Press air cushion cylinders. Now this is the panel we are putting onto the die, and this yellow piece will be having a bead shape. You can see that, right? This this is a bead shape here. See, you can see here what I was explaining. If you see little more, blank is came. Here you see the material is up here. Now the bead work is come into picture. Now the material will flow inside. You see the material is flowed inside. Parallelly, the shape has been taken up. You see this shape is taking up. Oh, first point of contact is this one. So first point of contact is this. So flow of material is happening along with stretching is happening there. So now this view you can see. You see this material is gone inside. This material is gone inside. Yep. This is one of the example. We have taken with suction cups this material out, this panel out. All right. This is how the mass production happen. Okay. So the next operation is trim die. How once we achieved the draw shape of the desired shape, or with all the analysis in picture, everything we have analyzed, everything we have gone through, and now we are coming to the trimming, how the trimming is happening and what is trimming. So extra shapes, extra surfaces, extra things onto the panel, we have to trim it out. Except those things which is use, which we have to take it forward and bend them or do the piercing operation also. So only those things will be left out. Rest of the things will be trimmed out. So how this trimming thing is going to happen is this. That is a simple press operation. It will simply trim it. Sometime it is a cam. So what is cam also I will tell you. These are all the components of the die. These are all common component of the press, blue shape, whatever you see. Those are common components, and whatever you see this white one, this will be visible on trim die. This is called trim chute. So here extra material, whatever extra material comes out, that goes to the scrap, and that scrap will also be useful. Okay, so our intention as a designer, our intention is to reduce as much as possible that scrap material. So now this trimming is happening. This is again, you can call it trimming or you can call it piercing also. All right. So from draw die, this panel came. From draw die to trim die, this panel came. With the help of that suction cups, then trimming operation is happening like this. Tool came, and if you see this two white thing, this two white thing opposite to that two white thing, there will be another two things. So these two things are holding up the material, so that when we trim it, it should not, the material should not flow inside. Otherwise, our shape will be get damaged. So we have to hold it properly. That is called hard touching. We are touching this hardly and trimming into it. This is holded properly. If you see here also, whatever the trimming operation, scissor kind of operation is happening here. So we have to hold this properly. Hello? Hello, anyone want to tell something? Yeah. So here you can see this is holding hard. This is called hard touch, and these are all important parameters while we do work in dies. While we work on the dies, or when we work physically onto the die. Right now, we don't see the importance of it, but this is very, very important parameter that we need to see to make the desired shape in a desired manner. So that is the important discipline we have to see here. Okay, you can see here how it is happening. This is scrap chute, through scrap, it is scrap. All right, once trimming is done, then flanging operation will be there. Flanging operation means B side flanging operation will be there. So the flange will bend inside. How that flange will bend inside after getting the draw shape, trim shape. Trimming means we have cut short the complete extra material, and now still sometime in as per the process we will be having some residual material, so we will trim it off in the next coming operations. Okay, so this is one of the operation. Now another operation is bend die. So if you see, upper side, lower side is mostly the same press, only changing shape is this area. Okay, where we are going to get the desired shape. So bending thing is going to happen in this. How the bending thing will work, or how we perform the bending thing, we can see here. Trimmed part shape came over here on this die. We kept it. Now bending thing is happening. Holding thing, if you see there, I'll show you this one. So if you see this yellow thing, only this touching thing, this is again called as hard touch thing. Okay, this is hard touch thing. This is hard touch thing. We have to hold that material in a proper place. Okay, once we hold that in a proper, that means this material we are safe. Whatever desired shape, we have that desired shape in place. Only thing, this is going to bend, so we are keeping some gap over there to make it a bend. If we close the gap, it will become a trim. So we are keeping a gap there. So bending is happening there. So the flange has been bent. But if you see, this flange has been bent, and after that, this flange came again back. What is that effect called? When we bend this bend comes back to or tending to come back to its original shape. This is a sheet metal. When we bend it, it will try to come back. So that is called spring back effect. You might have heard, you might have seen in your engineering. So that is the effect. If you see, once again, when it goes back, the spring back came. This spring back came. This is called a spring back. For that, we have to do some arrangement. How to get that desired shape? This is very important thing. This problem is everywhere. In aluminum shape is also there, or any aluminum material is also there, or whatever the sheet metal or steel material. Everywhere we face this problem. In sheet metal thing, everywhere we face this problem. So how to reduce that spring back? So in that case, there is one little concept, but very important concept is like we need to make this die shape little more inclined. Okay, we need to chop it off to give more bend, so that it will bend more and it will come back to the desired shape. Okay. Here, this parameter shows one parameter is there. If you see 3 degree, 3 degree is generally, or expertise says 3 degree is the spring back you see in the sheet metal thing, sheet metal steel thing. Okay, if you have a steel material, you will see 3 degree of a spring back. So that if we cut that 3 degree off from here on the die, it will bend more by 3 degree. Okay, so it will bend more by 3 degree. When it come to spring back, it will come in a desired shape. Okay, so uh, in I mean, like in the steel, we generally keep 3 degree as a and the whatever the activity we do to reduce this material, that activity is called compensation. Is compensation of a compensation for a spring back. Okay, so these terms, when you go in industry, you will definitely remember it. So whenever someone says we have to give some compensation, how much compensation we should produce, it is like for the steel thing, we have to give the compensation of 3 degree to get it compensate and get the desired shape. For the aluminum thing, we generally go for 5 degree. Okay, so that is the thing. Once bend operation is done, again suction cup came, taken out our material. Like that, bending operation will happen, and bending operation we will perform. Don't forget about this holding thing. This is called pad. This is not a draw. This is not a anything else. This is called a pad, or we call it bend pad. In trimming operation, we call it trim pad. So this is a trim. This is a bend pad. Okay. Now next thing is cam flange. Cam flange, basically. Cam flange. If we wanted to more bend into, let's say, if we wanted to bend more the flange, which is on angle, how to do that? There will be some cam operation. Cam operation is generally called when some angular or undercut areas are there. Undercut means which is not in the press direction, which is having some angle. We cannot see from the top view of the panel. So see, this is the bend operation. How this bend operation is happening. This is holded here, and bend is operating up here. So this area we call it a pad again, and this area is again we call it punch. So this is the this is how it is going to work out. There are multiple ways to have cam. Okay, so there are multiple automation thing will be there in the automotive industries, so that cam thing will happen. All right. So this is the thing. Is like we need to bend it inside. Here also the spring back effect is there, but here also we have to give pre-compensation thing, and then we can get the desired shape. Once bend is happening, yeah. All right. Okay. So one more quick video I'm going to show you. One of the video I got it from YouTube only. So BMW car factory assembly, how they are assembling it. So this is kind of a one good overview, and this is how the plant looks like inside the automotive car manufacturing industry. So these are all robots, which is going to here. All things will be robotic and which will be pre-planned and which will be programmed one. So no man will be available within this area. That is strictly not allowed. So till then, uh, uh, parallelly we will watch also. If you have any question, you can come up. Forum is open for you. Anyone has any question, anything, they can come up.
Anyone, have you asked any question? Please ask. There is a students of final year also, and they already taught the subject of vehicle body. Now, currently is they have a subject also vehicle dynamics. So this session would be a very helpful for them. If anyone have asked, then they are free to ask here. But one by one, they can ask the question.
These are all spot welding is happening inside. These are all sealing thing is happening. So you can see waterproofing thing. So sealing thing is happening here. All will be robotic thing. The sealing thing is happening here. This is probing thing. Sorry, sealing thing only. So rubber seals you might have seen. So those rubber seals are happening here, liquid form, and then this is the thing. This operation is happening on the roof. Gluing thing is also there. So gluing also they do. Roof is now put it on there. Yep. Roof is now placed. All the assembly sequences are more important thing while we plan any of the thing, any of the operation we plan. So assembly sequence is more important. Which one is coming first? Which one is coming last? So always we need to keep it in mind. Assembly sequence. So those are very important thing while we do any of the automotive vehicle work. Now this spotting thing is happening with the help of you see there are some guns are there. This gun is called C gun. Is called C gun. This will spot the weld. Spot welding is happening. So this gun is called C gun. There are many guns, types of guns are coming. So X gun and C gun are most extensively used in the automotive vehicle for welding things, and uh, if it required, we have to customize the guns also. So those are called customized guns. So, but those are not I mean, like readily available in the market. But these C guns and X guns are readily available in the market. So spotting things means BIW. We are welding with one with other. So that is the spotting welding, spot welding, and all the things are robotics only. So manual work, totally you see the boundary out of there. So people will not be available or will not be allowed to enter into it while robotic operation is happening. If anyone has any question on it or anywhere you want to stop, I can do that. Stamping thing or welding thing, all things will be planned station wise. There are multiple stations, depends on assembly sequence. So operation will be performed based on assembly sequence only. So after welding and everything, all the BIW shapes, body in white shapes we have done, and now we are ready for painting. So that painting is going on.
Students have any query?
Excuse me.
Yeah. Please go ahead. Any question? Sorry, I
Yes,
was on
sir.
mute.
Good afternoon, sir.
Yeah, please.
Sir, as I've seen during the assembling of all the parts of the particular automobile, so as all the things are done through robotics, so what are
Yes.
the perfection measures they are taken for the proper assembling of the particular parts by the manufacturer?
Or what are the proper measures they have taken? That is what question?
Perfection for the perfection, because as they are doing robots, so maybe there are some chances for the error occur during their assembly. So
Yeah.
what they how they overcome those difficulties during their manufacture?
Okay. So to answer your question, basically testing thing is also there in a picture. Okay. When we do some automation thing, all these things you have seen are called automation thing, right? So uh, we have a team. We develop programs, or we have a software also where we can see all the parts. 3D parts we were available uh, 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 in our shop. We have 3D parts. We have software available, automation software available. So we plan, sequence, or all the things we'll do on like programming, and after that we do testing also. It directly not go to the mass production. Okay, there are definitely error things will be there. So to arrest those errors, we'll be having testing. Okay, so we cannot directly go to the mass production. If it goes to the mass production, in 35 seconds we need to take out one car to the road. Basically, in 35 seconds we cannot accept the
Yes.
lead time, right? So there will be definitely a
Okay.
testing phase is there before releasing the program to the mass production. Is that what you are looking for?
But sir, the testing is done after the whole process is over, right?
No.
But
Testing before we have to
what
do it.
about when? Okay. Is there any?
Before we have to
Okay.
do the testing only, so that that program will be released to the mass production. Program will be released to the mass production so that our cycle time of one making of one vehicle should not be affected. Okay, so testing, every
Okay. Yes,
testing
sir.
of
Got
everything
it.
will be done beforehand only. Got the
Okay, sir.
point?
Yes, sir.
Yeah.
So, one thing I have to ask, sir, may I?
Yeah, please go ahead.
Sir, as electric motors vehicles are good for the development also, but how they are possible in India, as all the things are going on large scale. So, is it to find the way in a short time, or take a very long time for such happening in India, basically in
Okay.
India?
Is it Soumya, right?
Yes.
Can you repeat your question, please? Because you're breaking a bit in your communication. I mean, like in your conversation. Can you repeat your question, please?
So my question, yes, sir, please. Okay.
Yeah,
So my
please.
question is, as we have seen electric motors in a foreign level, as Tesla, BMW cars, Audi, and all that. Uh,
Yeah.
Electric motor cars, I'm particularly talking about. So
Mm-hmm.
as we have seen that the fuel vehicles like petrol or diesel vehicles are very challenging, because the cost price is going to high at each level.
Mm-hmm.
So it is very good for our country to introduce the electric motor vehicles on a large
Mm-hmm.
scale.
Okay.
So what are the measures we have taken so that for development of electric motor vehicles in India, and how they are possible? Because we have some other measures we have taken, as
Yeah.
to put a port of charging as
Mm-hmm.
done in a petrol pumps
Correct.
in nowadays.
Mm-hmm. Mm-hmm.
So it possible, or
Yeah.
how time it taken? Is it in a
Okay.
short period of time or take a large period of time for the development of such vehicles
Okay.
in our country, especially in
Okay.
India? I'm talking about.
Yeah. Got your point. So I'm also part of India only. So
Yes, sir.
what I see, the overall prospects, it will take another, decade till 2030. Okay, to come into the complete role, not complete role, but up to some extent, possibly 30 to 40%, we can have the electric vehicle on roads. Now, if you see, Tata Nexon is one of the example, right? Tata Nexon,
Yes, sir.
that is coming. I mean, our Indian automotive industries are now working with two platforms. Number one is the regular conventional vehicle which is going on. Number two is uh, not two, basically two, three platforms. So number two is hybrid vehicle which is going on, right? You might have seen a lot of hybrid vehicles also in the market, which we call it PHEV. So semi-electric we can say, and another one is fully electric mode. Our because of the infrastructure and everything, because of infrastructure, we are not uh, fully not merged into electrical vehicle because infrastructure is not available all over the India.
Yes, sir.
We cannot suddenly change the whole thing. You are the new generation. You are going to work out on that part. Okay. So, see, infrastructure means like vehicle charging. If I wanted to drive from, let's say, from Indore to Nagpur, so I need to cross like 350 or 600 kilometers in one shot or two shot, basically. I don't have that infrastructure in between where I can charge my vehicle. So once people started buying it, people started buying like Tata Nexon and some other Tata Tigor or some other vehicle. They started to buying it, but it will take slow motion, slow mode. I
Yes,
mean,
sir.
slowly,
Right.
once people started buying the vehicle, then demand start to charge it. Okay, right now, let's say I buy the vehicle, I have to charge it at my home only, and after that I have to find out in a bigger city where I have a charging point. I have to go there, I have to charge there and come back. So and second thing, I don't have the long range battery system also. Okay. Like Tesla is having a long range battery system. Right now, they launched the vehicle like Model X, what we saw on just first video, Model 3, Model X, Model Y. This vehicle having range of 600 miles. 600 miles, sorry, 400 miles. So if you convert it to kilometers, it will comes around 600 or 650 kilometers. Means it is easy for me to start from Indore to Nagpur. I don't have to stop for any charging. So that kind of wide range is not available in the India right now. Tata
In India,
Nexon is
yes, sir.
giving like 200 kilometer, 300 kilometer is the range, but that is ideal range. Okay, and our roads are not that good. Basically, uh, we are working on it. Government is working on it to make the roads perfectly to accept this kind of era. Okay, so yeah,
Yes,
government
sir.
and people, this is not going to happen. Not going to happen till we don't work on it. We have to work on it. People started to buying charging station. People started to buying electric vehicle. Now in small cities also people started to buy electric vehicle, but not like every house is having one vehicle. Okay, it will take some time, but yeah, in coming years, basically 4 or 5 years, you can see more of a electric. Okay. All right, it is possible in India. It
Yes.
is going to be
Yes.
possible
Right,
in
sir.
India for sure,
Right, sir.
for sure.
Thank you, sir.
Yep.
Anyone else who want to ask a question? I think, sir, they have already cleared their doubt. So we
Oh,
will just
nice.
close the
Actually,
session now.
I'm happy. People are. I mean, like our students are having good mind and they can understand everything in one shot. I didn't understood in first shot. I'll honestly speaking, I didn't understood all this concept in one shot.
Okay. So,
Yeah.
sir, I just would like to thank you for I would like to thank our today's guest speaker, that is Mr. Rajesh Pandagre, sir, for joining and enlightening our students with their knowledge. So today I think workshop
Yeah.
was full of knowledge and having interesting things. It gave deep insights into the topic and also revealed some interesting facts. So the point where he told is about the die phasing, I think was really informative, and this is new to students. And I'm pretty sure
Mm-hmm.
the previous knowledge that Mr. Rajesh Pandagre gave of students will definitely uh, help us in their studies and as well as future. So once again, thank you
Mm-hmm.
so much for making this session is very interactive, interesting, and also meaningful. Thank you so much.
Yeah. Before closing up, I just wanted a few words to. I just wanted to have few words with students basically,
Yes, yes,
and
yes.
the organizing team also. Like I wanted to know uh, my feedback, basically feedback in the sense like honest feedback, so that I can improve myself. I am always looking for improving things. I wanted to improve myself so that I can interact you more and I can present more realistic and more relevant topics. I can study that. I can go ahead and make presentations for you and do more interactions with you. So I just need honest feedback from each one of you. That will be really helpful for me.
Yes,
Yep.
yes, sure. Actually, already I have shared the feedback link in the chat box
Okay.
also, and all the
All right.
students will fill the feedback. Then we get the feedback, and I will also inform to you, sir.
Yep. Yep. Thank you.
Okay. Thank you so much, sir.
All right. Yeah. Thank you. Thank
And
you,
to
team.
all participants also for making this session
Yep.
very interactive and interesting. Thank you so much.
Yep. Thank you. Thank you very much.